A typical commercial freight train often measures about a mile in length. From a stationary crossing, a person can comfortably track its progress from the lead engine to the final car as a single cohesive unit. However, there is a threshold where a vehicle becomes so massive that standard visual processing fails to see it as one machine. Standard rail transport typically remains within these comprehensible, human-scaled boundaries. The Indian rail network has engineered a vehicle that operates far beyond these traditional limits. They named it SheshNaag, the longest train in the nation's history. At this magnitude, the SheshNaag functions as a rolling geographical landmark. The official measurements for the SheshNaag place its total length at exactly 2.8 kilometers. Laid over a city grid, the train's footprint cuts across dozens of blocks. Walking steadily, it takes 35 minutes to travel its length. The span is so vast, it encounters different weather, raining on the engine while rear cars sit under clear skies. The engineering crew and the guards are separated by such a distance that they rely on radio relays for essential status communication. Managing a 2.8-kilometer span requires the logistical precision of a mobile infrastructure project. Building a vehicle this long requires a massive assembly of modular units. The SheshNaag achieves its record-breaking span by linking 251 individual freight coaches together. These are heavy, industrial freight wagons, constructed from reinforced steel for the transport of raw materials. When 251 of these loaded coaches are joined, the combined physical mass reaches several thousand tons. Under acceleration, the metal couplings holding the coaches together must withstand immense structural stress to maintain the integrity of the chain. Managing this assembly requires constant mechanical endurance, far exceeding the demands of a standard rail yard operation. Moving a 2.8-kilometer, 251-coach chain requires solving the problem of massive static inertia. Heavy-duty electric locomotives provide the thousands of horsepower required to generate the initial pulling force. A single engine at the front would likely snap the lead couplings, so rail authorities distribute multiple engines throughout the train's length. This setup allows the SheshNaag to function as a synchronized network of distributed power nodes, rather than a traditional single-point pull. Once the SheshNaag leaves the terminal, its true scale is visible against the open landscape. As it snakes through the valley, the massive steel structure has to physically conform to the natural curves and elevations of the terrain. Moving a 2.8-kilometer rolling wall requires rail authorities to carefully clear the national network to prevent total logistical disruption. The SheshNaag remains the undisputed record holder for the longest train in the history of the Indian rail system. It serves as a definitive benchmark in engineering, marking the current physical boundaries of rail logistics.